I'm going to show how to create a Phong lighting effect using Affinity Photo's procedural texture filter. I've got a just plain blue background here. Now I'm going to turn on the filter effect for this. And so you can see it adds a, there's really three different types of lighting that occur with this effect. I have ambient lighting, which brings up the ambient level. I have diffuse lighting, which controls the sort of the overall texture, and before I called that bump map lighting, but that's what I'm using for my diffuse lighting. And then I now have added specular lighting, which adds this sort of shiny effect to it. And I can control the direction of the light source or the direction of how you're looking at this, and depending on how you look at it, that reflection of light will change. You can also make it more or less shiny, so I could, if I reduce this shininess factor, it becomes a little more not quite as shiny looking, not as smooth of a surface, so sort of a rough surface it would be. And then if you want a real smooth, highly reflective surface, you make the shininess factor larger, and you can make it look real shiny. So I'm going to go over how I set this up and show how to implement something like this with the Affinity Photo procedural texture filter. To get started, I'm going to delete this one and start with a new one. Okay, so I'm going to go ahead and add a live filter, procedural texture. I'm going to just add one of these, and I'm going to apply it to all three channels. I'm going to start with a vector. I'm going to call it V1. It's just a vector of Rx and Ry multiplying by A divided by W. This is my scaling factor. I'll just call it scale. And I currently have that set to 6. So I'll just set that to 1. And I'll just show what that looks like. I have a blue background before, but now it's going to look like that. Because it's relative X, relative Y. If I double click, I can drag this over to here if I want to. But I could increase the XY scaling to show it like that. I'm going to set up 4 of these. 2 of them will be for the X dimension, 2 of them will be for the Y dimension. And I want to take plus or minus 1 pixel on either side for X and for Y. So the first one is Rx minus 1, then I have Rx plus 1, then I'm going to bring in vector 3 with Ry minus 1, and then Ry plus 1. So those are my 4 sets of coordinates. I then have to apply these to, I'm going to set up, for the next thing, I'm going to use Perlin noise. And so for that one, I need to have an octave and a smoothness factor. So I'll put in my octave factor here, call it O for octave. Set that up to about 7, because I want to have a fair amount of opportunity for a fair amount of noise with this. And then the smoothness factor, S, smooth. And that'll just go from 0 to 1 as a factor with that. So I should be able to, just to check to make sure everything's working, I'll put in NZ1 here. And I'm able to get this noise applied to that. You see I have this set to hard light, so I'm going to change that over to normal. And if I wanted to, I could change it to hard light. Eventually I'm going to have hard light. I could put that in down here too. So I think I'll leave it down here rather than up there. I need 3 more of these, 1 for each of the 4 coordinate systems. Other than the coordinate systems, these are the same. Next is get the normal map. So I'm going to use these to generate a normal map. To create the normal map, I'm going to look at the slope in both the x and the y. So I'm multiplying it by this b factor, which will allow me to sort of artificially increase the slope. If I'm at a low magnification, there may not be much difference between the pixels on either side of this. And this b factor will allow me to sort of magnify that effect. Anyway, I have to add 1 to this, and then I'm dividing the whole thing by 2. I do the same thing with noise 3 and 4 for the y dimension. And then the blue coordinate, this will be red, this one's green, and then the last one, blue, will just be set to 1. So that's how I set to 1 for the normal map. I'm going to call that NM. Okay. For the diffuse lighting, I'm just taking the dot product of the normal map and the lighting source. So I need a lighting source. I will add that. I'm going to call that L. This will be the source of my lighting. I'm also going to add in one called E, and that will be my eye, where I'm looking at it from. I'll call it E for where my eye is. Okay, I need to put in this factor B to increase the amount of slope, so I can control that. Next thing I'm going to do is create the diffuse lighting, which is just what I call my bump map before, but now I'm going to call it DL for diffuse lighting. It's going to be the dot product of my normal map and the light source. And I'm going to give that, I should be able to show that with the DL here and just make sure everything's working okay. So there's my diffuse lighting. It's pretty bright. I'm going to add a factor for that. I'll call it, I'll just call it I1, but that will be for my diffuse lighting. And then I'll also have this B factor is for my slope. So it's going to magnify my slope. So I should be able to bring that up. You'll see that the slope is increasing, and then I need to multiply my diffuse lighting by this factor I1. So I'll take that I1 times the diffuse lighting. Okay, so then I can bring this down and bring this up, and I can increase my slope more or less. Now as I change my scale on this, the slope will automatically increase, because you can imagine that, oh, now I have a greater difference between the different pixels on the screen. Next thing I have to do is set up the specular lighting. So I'm calling that variable SL, and it's I first have to create a vector for the half angle between your eye and the lighting. That is created just by taking the direction of the lighting and adding it to the vector for the direction of your eye, and then normalizing that. Then that's the half angle. Then I take that, the dot product of the normal vector and the half angle, and that is the specular light. But in order to make that look shinier, I use the power function to raise that to a power of the shininess value. And you'll see that shininess goes up, can go up quite a ways to make it really look really shiny. So I'm going to take that, I'm going to bring that in over here. As a specular lighting. And let's see, so I need a factor for the shininess. That's going to be, I'll just call it SH, and that is, I'll call it shiny. And it needs to be fairly large. I'll just set it up to 10 for now. And then I need to add in a, so over here, I have to add plus an I2 times my specular lighting SL. And so I need to add in something for I2. So I'll just call it I2, and that is specular lighting. And And I'm going to bring that down for now. So let's see what that looks like. So I'm going to turn off the diffuse lighting, and now I have the specular lighting. And so when I bring that up, you can see that's what it looks like. But as I change the position of how you're looking at this, it's moving that around. And then I could also change the light source, and it'll sort of move it around too. So it sort of interacts, these two sort of interact with each other. But the other thing I can do, if I increase my shininess factor, let's try that. All right, it will make this, I'm going to bring the smoothness down a little. Yeah, it makes this sort of smaller, but it makes it look more shiny. And so I can add some more diffuse lighting to this, and there I have that, you know, highly reflective shininess right on top of there. And these two sort of interact with each other. Where you are in the circle is the direction, and then how far over it is, the lower the angle is. So the further over you go, the lower the angle is. And this is how you're looking at it, both the direction and the angle of how you're looking at it. Okay. The last thing I could do is add some ambient lighting, and that I'm just going to have an I3, and that I'm just going to add that in directly. So this is the ambient, and you just add that on. So plus I3. That's way too much. Okay, so I can bring in a little bit of ambient, and that's going to light everything. So I'd start with, you know, I might start with these all the way down. Can increase the amount of ambient. Bring in the diffuse lighting next, and then bring in the specular. And you could leave this all the way off and just rely on these two, but if you're getting too much contrast there, and you could bring this one up a little bit to add a little ambient lighting. If I bring, I could decrease the slope so it's not, doesn't look like so much depth, and then if I change bring this down, it should make it look so it's not quite as smooth of a surface. So this should make it look like it has more of a rough surface on it. I learned how to do this effect by watching a video series by Ben Cloward. Ben has a series of videos on creating textures. They're designed for other programming environments, such as the Unreal Engine, but you may be able to adapt them to Affinity Photo. Let me know if you have any comments or questions, and thanks for watching.